Okay, show you know from section 11.2. So a cafe offers 4 types of sandwiches: egg salad, tuna, ham, or turkey, on one of 3 types of bread: wheat, rye, and whole wheat. So the first thing says use a table to determine the number of combinations offered by the cafe. So our table here, we're going to put, doesn't really matter, we're going to put egg here, we're going to put tuna here, we're going to put ham here, and turkey here. And then on the other side, we're going to put white, rye, and whole wheat. And you could use whatever you want for your abbreviations. You can write out the whole words, it doesn't matter. But for purposes of a table, this clearly shows us what we need to know. It wants that how many, the number of combinations. So we said last date, this area in here is called your sample space. And what this basically does is tell you how many different combinations there are. And in this particular case, your sample space actually tells you what those combinations are. But we don't even care what kind of combinations there are. We just want to know how many there are. And we can clearly see that the number of possible outcomes are 12. And if you wanted to write them out, you could go egg on white, a tuna on white, a ham on white, and a turkey on white. Those are 4 of the 12 combinations, and I could fill it in if you wanted to. But then the second part says check using a different strategy. Colin, you seem to be an intelligent young man. What do you think another strategy is for determining how many possible combinations there are, besides a tree diagram? What else could we do to figure out how many combinations there are without taking the time to make this table? Yes, multiplying is the answer. So here's what the new method looks like for calculating the number of possible outcomes. I want you to define what it is. I'm going to put sandwich, what does it call sandwich? Yeah, sandwiches and bread. So how many sandwich combinations are there? There are 4. There are egg, tuna, ham, and turkey. How many bread combinations are there? There are 3. If you multiply those 2 together, you get the answer, which is possible combinations, right? Or possible combinations that are available. So in this case, remember what we said before, our top one is our favorable outcomes, our bottom is our possible outcomes. So really what we're doing is we're ignoring the favorable outcome because we're not looking for anything specific. We just want to know how many possible outcomes are in the first event, how many possible outcomes are in the second event, and if I multiply those 2 together, I will figure out how many possible combinations are. There's 12. Okay. This is a quick way of doing it. This way here allows us to see what those combinations are. Right? If I want to know how many of them are tuna on rye, I can clearly see that there's only one combination out of those 12 available that's tuna on rye. Right? Here, I can't see the combinations. I just know how many there are. Okay? Does that make sense? So the new method that we're using is simply multiplication of the individual probabilities of them happening. So in this case, 4 different possibilities multiplied by 3 different possibilities gives us 12 possible combinations. Okay? Clear? Perfect. The second show you know says a cafe offers 3 types of sandwiches with 3 types of bread and one of 2 side orders, carrots or chips. How many possible combinations are offered by the cafe? So for this particular one, since we have 3 different events, you can't use a table. You have to use a tree diagram. And again, this is probably the maximum number of branches I would ever want in a tree diagram. But what I'll do is I'll pause this and show you what it looks like. So when your tables, or when your tree diagram is done, we can see that if I take my highlighter here, this particular one that I'm highlighting, cheese on whole wheat with chips, is one combination if you follow that branch all the way down. So what I can do is I can say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible combinations of sandwiches, breads, and side accoutrements. There are 18 different combinations. specifically cheese whole wheat chips, or if I took my highlighter again, you could have a tuna on spelt with carrots. That's another combination, right? But there are 18 total possible combinations. But again, if we use that new Collins strategy that he said multiplication, if I think of my sandwich as being my first, my bread as being my second, and my side as being my third, there are 3 types of sandwiches, there are 3 types of breads, and there are 2 types of sides. The product of all 3 of those events, 3 times 3 is 9, times 2 is 18. It tells me that there are 18 possible combinations through just the multiplication of individual combinations. Does that make sense? So the first part is a grade 7 outcome. This was learned in grade 7, nothing new from grade 7 and grade 8, creating a tree diagram to calculate possible outcomes. The new addition to your repertoire of knowledge is now saying, listen, instead of doing that, just multiply the individual combinations together to get the total number of combinations available. Okay?